Hello, geometry students. Mr. Cazzato here. Today we want to review the area of a circle and then use the area of the circle formula to find the area of a variety of composites. We're also going to work backwards. So if you remember, the area of a circle is pi times the radius squared. And the radius, remember, goes from the center of the circle to the outside of the circle. So in problem number 1, we want to find the area of a circle with diameter of 16. 2 times the radius is equal to the diameter. So 2 times the radius is 16. That means the radius is equal to 8 when you divide by 2. So we have to do that first. Then the area is pi r squared. And the radius is 8, so pi times 8 squared. So the area is going to be 64 pi. Now, most SATs and ACTs want us to leave the answer in terms of pi. So we will leave the answer like that, and the unit would be centimeters. However, in a lot of applications, you might need to get the decimal. So the decimal is around 201.06 centimeters. All right, if you look at problem number 2, the area of a circle is 16 pi centimeters squared. And we want to find the circumference. So there's a typo on that handout. So step 1 is we know the area is pi r squared. So 16 pi is equal to pi radius squared. When you divide by pi, the pi is reduced to 1, so 16 is equal to r squared. And then we take the square root to get the radius, which means the radius is 4. And it's 4 centimeters. Then step 2, we want to find the circumference. So circumference from the previous unit is 2 pi r. So the circumference is 2 times pi times 4. So the circumference is 8 pi centimeters. Again, if you need the decimal, you could use the pi button on your calculator, and you'll get around 25.13 centimeters. Let's take a look at problems 3 and 4. Number 3, we want to find the radius of a circle with area 4 pi meters squared. So using the formula, A equals pi r squared. We're going to plug in 4 pi for the area. That's equal to pi r squared. Divide by pi. And some of you may realize the pi is reduced, and you'll go right to this step. 4 is equal to r squared. You take the square root of both sides. So then r is going to be equal to 2. In problem number 4, find the diameter of a circle with area 81 pi kilometers squared. So area is again pi r squared. So 81 pi is equal to pi r squared. Divide by pi. 81 is equal to r squared. Square root of 81 is equal to r. So the radius is 9. However, the diameter is twice the radius. So the diameter is 2 times 9, which is 18 kilometers. The next couple of problems, we're going to be looking at composite figures. So we look at example number 1. Sort of looks like a portion of a basketball court. So we have want to find the area of the shaded region. So one way to approach this problem is we could find the area of the rectangle. So the area of a rectangle, we got 33 feet at the bottom. The height is 16 feet. So the area of a rectangle is base times height. So we would do 33 times 16. And we'll get 528 feet squared. Then we want to find the area of the rectangle without the semicircles. So if you look at the picture here, I'm going to shade, that's half of a circle, that's half of a circle. So I'm going to find the area of the circle. So the area of a circle is pi times the radius squared. Looking at that diagram, the diameter is 16 feet. Divide by 2, the radius is going to be 8 feet. So the area of the two half circles put together is going to be pi times 8 squared, which is 64 pi. And because we want to find the area of that shaded off white color, we're going to subtract the area of the rectangle minus the area of the circle. So the area of the shaded section is going to be 528 minus 64 pi, and the unit here is going to be feet squared. If you want to get the decimal on that, you would type that in your calculator. And when you type that in your calculator, that is approximately 326.94 feet squared. Take a look at problem 2. See what shapes you see. So in problem number 2, I see 3 shapes. I see a triangle, I see a rectangle, and I see half of a circle. So I label them 1, 2, 3. So section 1 is a rectangle, and the area is base times height. And the base is going to be this 20 centimeters, which is going across the top. And the height of the rectangle is this 14, which I'm shading in green. So for the rectangle, the area of section 1, it's going to be 20 times 14. And 20 times 14 on our calculator is 280 millimeters squared. Section 2 is a triangle, and the area of a triangle is 1/2 base times height. And the blue piece is 20, so I just highlighted that there. So if the blue piece is 20, I'm going to put 20 here. To find the yellow piece, I would take the whole segment, which was 32, and subtract 20. So the little yellow segment is 16 millimeters long. So the area of the triangle then is going to be 1/2. 16 is the base. And the green segment is the height, and we know that height is 14. So doing that on our calculator, 1/2 times 16 times 14, I get 112. So the area of section 2 is 112 millimeters squared. And then I need to find section 3, which is half of a circle. So the area of a circle is pi r squared. The 20 is equal to the diameter, which makes the radius 10. So the area of the circle is pi times 10 squared, which is going to be 100 pi. But there's a second step because that's not a full circle. So now we need to take that 100 pi and divide by 2 to get 50 pi millimeters squared for section 3. So to recap here, we have section 1, 280 millimeters squared, section 2, 112 millimeters squared, and section 3, 50 pi millimeters squared. To get the final answer, I'm going to write that up here, final answer, we're going to add all of those together. So we have 280 plus 112 plus 50 pi. 280 plus 112 is 392 plus 50 pi. That is the exact answer. And if we use our calculator to get the decimal, this is approximately 549.08 millimeters squared. So I'm going to highlight the final answer. The exact answer is in blue, and then the decimal approximation is in green. Let's turn the page and take a look at the next couple examples. So if we look at example 3 at the top of this page, we have two sections. We have this red section, which is half of the circle, and then we have the blue shaded section, which is a rectangle. So we have two parts. We have to do half of a circle. So the area of a circle is pi r squared. After we figure that area, we're going to take half of that answer. And then we need to find the area of the rectangle, which is base times height. So the area of the rectangle is going to be 10 times 15. So the area of the rectangle is 150 square inches. For the circle, the diameter is equal to 10, which makes the radius equal to 5. So we're going to have pi times 5 squared for a full circle, which is 25 pi inches squared. But we only want half of the circle. So half of the circle is 25 pi over 2 inches squared, which is 12.5 pi inches squared. Since we want the area of that whole shape, we're going to add the two areas. So the third step of this problem is to add the areas. So we're going to have 150 plus 12.5 pi inches squared. And using your calculator, you can get a decimal approximation for that. I get approximately 189.27 inches squared. Let's take a look at example number 4. Example number 4 has a triangle at the top, a rectangle, and then a semicircle. If I take a look at the triangle, I'm going to draw the triangle out over here. I need to find the area of this triangle. I know the hypotenuse is 10.2. And looking at the diagram, this green piece is 7.8. This yellow piece is 3. So in order to get the height of the triangle, I'll call it h, I'm going to do h is equal to 7.8 minus 3, which is 4.8. So the first thing I needed to do is figure out the height of the triangle. Then the next step is I need to figure out the base of the triangle, which is this bottom piece that I just highlighted in pink. We know that a squared plus b squared is equal to c squared for right triangles using the Pythagorean theorem. So I can say 4.8 squared plus b squared is equal to 10.2 squared. Using my calculator, I get 23.04 plus b squared equals 104.04. I'm going to subtract 23.04 from both sides. And I'll get b squared is equal to 81. Take the square root of both sides. So b is 9. So the base of the triangle is 9, which is also the base of the rectangle. So now I can find the area of the triangle. The area of a triangle is 1/2 base times height. So the base is the 9 that we just calculated, and the height is 4.8. So doing that on my calculator, I get the area of the triangle is 21.6 feet squared. The area of the rectangle is base times height, which is 3 times 9, or 27 feet squared. And then we have the area of the semicircle. And let me just find the area of a circle first, then I'll do the semicircle. So the area of a circle is pi r squared. Since the diameter is 9, this 9 is the diameter, the radius is half of 9, which is 4.5. So doing that on my calculator, I get this is approximately 63.62 feet squared. And the goal was to find the area of this purple shaded region. So then the area is going to be adding up all those different shapes, the triangle, the rectangle, and the semicircle. And I did forget to divide the semicircle by 2. So the area of the semicircle is half of 63.62. So when I divide that by 2, I get 31.81. So the area of the semicircle, I'm going to highlight that in pink. We have the area of the rectangle, I'm going to highlight that in pink, and then the area of the triangle. So I'm running out of space here, but the area then would be adding up. So I'm going to put this in a little box. You would add up, so the final area is 21.6 plus 27 plus the 31.81, and that's going to give us a final answer. I need to grab my calculator here. Of 80.41 feet squared. So this is the answer I'm going to put in a box since there's a lot of work on this problem. Okay, let's take a look at this example that's on the screen on the left. It looks like we have a triangle and then we have a little half of a circle taken out. So this is going to be a two-step process. First step is I'm going to find the area of the triangle, which is 1/2 base times height. Remember, always look for the right angle to help you figure out the base and the height. So the base and the height are the 26 and the 18. So the area of the triangle is going to be 1/2 26 times 18. So doing that on my calculator, I get 234. The second step is I need to find the area of a circle, which is pi r squared. That 9 here, I'm going to highlight this in pink, is the diameter of the circle. So if the diameter is 9, we should know that the radius is half of that. Half of 9 is 4.5. So pi times 4.5 squared. And when I do that on my calculator, I get approximately 63.62, which is the same dimensions as the earlier one, but we need the semicircle, which means we're going to take this answer 63.62 and divide that by 2. So we get 31.81 is for the semicircle. Because we want the area of the shaded, step 3, the area of the shaded part, we're going to subtract the triangle, 234, minus the semicircle. In doing that, the final answer here is 202.19 square feet. So this is the area of the shaded section. Okay, the last example, we have a trapezoid and we have a circle surrounding it. So I'm going to find the area of the circle, which is pi times the radius squared. Looking at this problem, 20 is the diameter, which makes the radius 10. So the area of the circle is pi times 10 squared, which is 100 pi centimeters squared. My goal is to find the area of the shaded section, so I need to find the area of the trapezoid. So the area of a trapezoid is base 1 plus base 2 times the height divided by 2. Looking at that trapezoid, the bases are 12 and 20. The height is 8. So the area of the trapezoid is 128 centimeters squared. And I want the area of the blue shaded area. So the third step is to subtract. So we're going to subtract 100 pi minus 128, and the unit is centimeters squared. So this would be the exact answer that you might see on an ACT. If you wanted the decimal, and you type this in your calculator, that is approximately 186.16 centimeters squared. If you have questions, please ask your teacher during class.